In this video, we're going to cover how to find the horizontal tangents of a function. So let's jump in. So here's the question. Go ahead and pause the video and see if you can figure this one out. So here are the answers. If you got these, then feel free to skip the video, but if you're not sure, stick around and we'll cover exactly how we got these. The first thing that we can try out is to actually experimentally just look for where the horizontal tangent lines are. So here I have an animation that automatically graphs the tangent line. I've plugged the function in that we're dealing with for our example. And basically, if I move this slider, I can also move it around here. I can basically see where the horizontal line is tangent. So here, and again, you can kind of see that as we keep going to the left, it gets more and more vertical in a positive direction. Apparently, when we get around here, this looks like, I don't know, but somewhere between negative 3.3 and 3.4. Whoops, negative 4 to 3.3. This is actually the negative 10/3 answer that we found before. So that one, it turns out, makes it horizontal. That's good. And then the other ones, that's positive 3. If I come down on this end, if we continue along, now things are negative, still not horizontal. And apparently, when x is equal to 0, we're also horizontal, and then after that, up again. So it seems like, the two answers that we showed visually are the only two spots where the tangent line is horizontal. So there you go. That's visually the answer, but obviously this option, this Desmos animation, is probably not available to you while you're answering these questions. So how would we answer this without knowing that? Well, think about it. What does a horizontal tangent line really mean? It really means that it has a tangent line whose slope is 0. And what do we know that measures the slope? Well, the derivative. At any point, the derivative measures the slope. So really, another way to word this question is, for what values of x is the derivative 0? That's another way of understanding it. And if we understand that, then it's actually not too difficult to solve this. So now let's actually work this through now that we know that that's what we're looking for. So here, basically, just take the derivative of this function, set it equal to 0, and solve for x. That's essentially what we're doing. So let's do that. So if I take the derivative of this, I get dy dx equals 3x squared, just using the power rule here, plus 10x, power rule and the constant multiple rule for that one. Well, that would be plus 0. So there you go. That's the derivative. And remember, we have horizontal tangent lines whenever the derivative is 0. So we can literally just set this equal to 0. Now, if this is equal to 0, it's not really obvious, I would say, looking at it, what x values would make this 0. But this is where factoring can come into play. And here we actually can factor a little bit. Specifically, I can see that we could factor out x. And if I do that, hopefully it's clear that I'm left with 3x plus 10. So now that we've done this, we basically have two separate factors, and the thing on the left will be 0 if either of these is 0. That's kind of the key insight. This is the 0 factor property. So if we set x equal to 0, then the left will be 0. But also if we set 3x plus 10 equal to 0, the left will also be 0. Because anything times 0 is 0. It doesn't matter what the other stuff is. So here, this one's kind of already solved for us. So x equals 0 apparently makes this work, which we already knew from the answers. And then if we solve this, we get x equals the other answer, negative 10/3, which was what we saw on the graph of negative 3.3 repeating. So there you go. That's how you find the x values at which you have horizontal tangent lines. And by the way, we could have, when we worked through this problem, again, it didn't happen in this case, but we could have gotten a result where we didn't have any zeros. So there could have been no values of x that made this 0, and in that case, that would just mean there are no horizontal tangents. But in this case, we have two specific values of x that cause horizontal tangents, so those are the answers to this one. Hopefully that makes sense. If you want to use the animation, it's pretty helpful for graphing tangent lines that we used in this video. Be sure to check the description, but other than that, I will catch you next time.